Yoksa sen de hocaların yanına oturuyorsun. Hocanın nasıl anlatıyorsun?
Yalnız dün sordum, 4 tane soru sormuş arkadaşıma. Dedim ortaya mı sordu, kişisel mi sordu, öyle de sorduğu oldu, kişisel sorduğu da oldu. Böyle sorular kolaymış. Haberin oluyor.
Ben şu yapayım. Video yapar mısın abi?
Let's just assume that it's our teachers and coaches.
Okay. Okay. So let's get started. Please.
Oraya geçersen başlayalım.
No man, this is just a outro.
Hello. Today I will start our poster about differences between alternating current and direct currents. But first I want to talk about electric. Electric charge is necessary from matter, and it is produced by fundamental materials and particles such as electrons and protons. Electric is the accumulation and motion of these little particles such as electrons. Electric is discovered in Greek at the 17th century by rubbing materials like plastic to materials like feather, and this interaction led to studies like static electricity and stationary charges. And within the discovery of the electrons in the 19th century, the age of the electricity has begun. Electric current is either resulting dynamically or statically. Therefore, we can divide electric current into two different types: alternating current and direct current. AC and DC for both abbreviations. DC was discovered by Thomas Edison, and DC is not very perfect in some of the uses, such as it's not very good for transforming huge voltages. It's not very efficient. Then Nikola Tesla had a different idea from Thomas Edison, and these two scientists had some divergences. Nikola Tesla tried other ways to use currents, and he discovered the alternating currents, as you know, AC. AC cleans up some of the flaws of the direct currents, such as it's easier to transfer, but it's not very efficient. But you can't use it at some machines because of the way of alternating current works. The purpose of this study is try to explain both AC and DC in depth and the way their usages. And I will leave my words to Jumali for the next part.
Thank you. Electric current, let's talk about physics. As we know, inside atom there are neutron, proton and electrons. Inside nuclei, proton and neutron are connected to each other by nuclear forces, and electrons rotating around that nuclei inside orbitals. As we know, protons and electrons are charged particles, so while these electrons are rotating, there is a potential energy of the electrons. For creating electricity, we need charges to move. We need moving charges. The most used one is electrons. So we need to separate electrons from the atoms and let them to move. There are 6 ways for separating electrons from the atoms, and via that way we can create electricity and electric current. These ways are friction, pressure, heat, light, chemical, magnetism. The basis of these ways are giving enough energy to the atom to separate electron from the atom. Friction, as we all familiar with, rubbed pen pulls little paper pieces. It's basic of the friction. Pressure and heat also can separate electron from the atom. For example, if you heat gases, it will turn into the fourth state of the matter, which is plasma. And light, we know light made of photons, so if photons hit the electrons, electron will separate also. Chemical, as we know, some elements has a tendency of giving or taking electrons from for taking electrons. So using that attribute, we can separate electrons from the atoms. Magnetism, we know from Faraday and Henry, changing magnetic flux causes a magnetic force on charged particles. So these ways can be used. As we can see, there are two types of electric current: DC and AC, direct current and alternating current. In direct current, electrons move from high potential to the low potential with a unidirection. The direction is fixed, not changing, but the magnitude of the current can be changed. So this is the definition of the DC, and there is a figure, as you can see. It's a DC source. It's a very common DC source. It's lithium-ion battery. This is schematic of the lithium-ion battery, simply. As you can see in anodes, lithium ions, lithium components. There are lithium components, and these lithium components separate by some chemical reactions, and as a result of that, lithium separates to lithium plus ions and electrons released. This lithium ions moves via that electrolytes to the cathode, and these electrons moves via that cable. And as you can see, the moving of these electrons creates a DC current, and these electrons go to cathode, and again in cathode, electrons and lithium ions are connect, and then lithium element is produced again. This is the discharging situation. While charging, the opposite things happen. This is the alternating current. Currents changing direction of the current by changing potential in terminals, and this happens periodically. So voltage and current change periodically. So it means that there is a period and frequency terms. As you can see, there is a figure. It's AC generator. In this AC generator, an external force such as winds, water, or steam is rotate turbines, and this turbines connected to this frame. And while this turbine is rotating, this frame is also rotating. When this frame is rotating, the magnetic flux passed through this frame is changing. So according to Faraday's flux law, if the flux is changing with the time, electromotive force is produced. So this is the alternating current. Now Ömer will talk about the application of these two currents.
Thank you, Cumali. Now I want to explain the application part. My name is Ömer Mert Yıldız. My department is electronic engineering. Now I want to explain the transportation of electrical energy. Transformers transport the electricity. It works mutual induction between two coils. These AC source, AC in transformers we use AC. When we use DC, it is a problem. We have two coils inside the transformers. One transformers cannot transport the electrons from the second coil. And the magnetic field is constant when we use DC source. But if we use AC source, this transformers can transport first coil to second coil. And we know AC voltage can increase or decrease. And you can see this picture. It's this power plant produced 12 kilovolts, and it's approximately exactly. And you can see it's a step up transformers. It increased this voltage, and you can see this lamp posts. After that, you can see step down two times. One of them decrease, and also the second step down transformers decrease the voltage. After that, you can see at home it's 240 kilovolt volt, but in Turkey we use 220 volt. It's pulse in our Turkey. And what can I say? Charging. When we talk about the charging, AC voltage constant changing, I want to give an example for this. Everyone has a smartphone now in the world, most of people, and we can think about when we tear down the smartphones, we can see the battery. Battery is the most significant part of the technological devices, and the batteries discharge. When this battery is discharged, we should charge the battery and use the telephone again, so that we use adapters for this one. Adapters convert the AC to DC, because in our home the electricity comes AC from the outside, but we use DC source. It's like a converter, we can say. And when we talk about the which device use what, AC use fridge, washing machine, dishwasher, air conditioner, oven, iron, fans. You can see the resistor is shine out. Like if you see a resistor, it's used AC. When we talk about DC, television, computer, smartphones, train, tram, metro, electrical motors. Also, we can see the battery. If we see the battery inside the devices, we can say it use DC. I give my turn to Onur.
Turn.
Turn mu dedim ben?
Turn dedim mi? Turn.
Okay, guys, keep going.
So, for ending the poster, I will continue with discussion and conclusion. With all things being said from my group members, we can say that DC's production and transportation costs a huge amount of energy compared to AC, and AC's transformation transforming AC to DC is easier way to use electric for efficient way. Therefore, in generally, production and the transportation is handled by AC, and with the using the required current changers such as transformers and adapters, we are changing the current in our home that that device we need. For example, for refrigerators or for the radios or cell phones. And to conclude, this study just tries to explain AC and DC in depth and the way of their usages. Therefore, it's not explaining something new or revealing anything new. It just reveals. It just reveals everything we got in the end at the moment, our hand at the moment. Future research might be able to find different ways to use the currents, or maybe a different way to use the electricity. Thanks for listening us.
Thank you.
Bakalım kaç dakika oldu?
Ha? Sen niye bana verdin?
Sevmiyorum belki abi. Bak bakalım.
Beni 4 geçe aramışsın.
Çok uzadı ya.
Beni 4 geçe aramışsın, 15 dakika falan oldu herhalde.
13 dakika olmuş.
Evet, geçen 13 dakika olmuştu.
Tamam.
Ben bayağı konuştum lan.